like it went to the background of the project here.
But also the whole Quiz project is in there.
But you're using what kind of
This plug that was already here.
Maybe when it's hanging, it's not good.
Maybe it's losing. I can put it there. Oh, if it does it again, you can.
Okay.
Now it's stable.
He put a lot of work into making like a build system that could do it's decomposition right now, but it could wrap any C OpenGL program, and then you can do Python and the wrappers. That's for like deconvolution only right now. And the rest of the project, they have a similar idea, some build system that Stefan is working on that will wrap it in Python and Java. But I don't really know the status right now. And then so there's the original Pledge, right? And that was all like mostly Java code with OpenCL kernels. And then they wanted to make it more like C code, so you can call it from anywhere.
I'm not sure
I don't
this
know
one's
how to do that.
There, yes.
But you use that code quite a bit.
Well, so when I started, a lot of Robert's stuff was like really appealing. I thought it was a really nice like Fiji to Napari transition.
OpenCL is nice that way.
And so I used it for a really long time. And what I don't know is it didn't seem like a lot of people in the Python space adopted his stuff.
Mm-hmm.
And I've always wondered is it because his stuff is good if your thing fits on the GPU, but then when you have bigger stuff that you need like Dask for, does it slow down? So I used it for years. Like I almost always, like if I'm writing code for myself, I just always use the Pronto code.
Mm-hmm.
But I never see it used in Python materials, and I did besides Robert's instructional stuff. But I just didn't know. I figured you two, if anybody, I would know more about it than, because no one else who really talks to like know of it, and I don't know why. It seems incredibly useful to be able to do cross-platform GPU code, but
It's a bit baffling to me as well, because the explanations that I can think of don't really hold water. I mean, the only thing I can think of is it's a social thing, where Python people want to be in Python, Java people want to be in Java, and then this thing's kind of neither. Like requires this third thing, but the third thing is so portable that seems like it should be a strength. And then the other thing I think of is, oh well, it wasn't well advertised enough. But then like Robert did, right? He did.
I mean that's how I knew about it.
Yeah, exactly. And he's prolific when it comes to outreach. So it's kind of like, well, how much better advertised could you even make it?
Well, I think one thing that happened is he switched from mostly image analysis to LLM stuff.
That's true.
And he was like a really, I think he went to a new place, and he, right when that was sort of maturing, his like, I don't know if drop is the right word, but his focus like totally changed.
He wasn't as
Yeah, so I don't know if that's what lost the momentum. That's kind of what I thought. But I also wasn't around before kind of I started, of course, in like 2022. So I didn't know. But even when I was using ImageJet, I was like, oh, I want to use this stuff. But that was a little bit advanced for me at the time to figure out how to use.
I guess we could ask Stefan.
Yeah, because I would love, I think the Napari Assistant is one of the coolest plugins ever made.
Yeah.
So.
So, I think it's just maybe it's just like defining who's maintaining it right now, and just like if it's Stefan, maybe just like drop him a line and
maybe I will actually reach out.
Which Stefan is it?
It's like S Rigo, I think. Stefan Rigo. But what's weird
is
is
Johnny's group. Yeah.
The sad part is, and I don't mean to say this too loudly, is the PyClasPronto project, I think, is the C++ like version of whatever PyClasPronto prototype was. I don't know enough about it.
Well, there's Klege and there's PyClasPronto.
Right, and so that's what he's taken over.
Which
They
one were you
don't seem
using?
to be any good. I was using the prototype because that's all that existed at the time.
Okay, were you using Klege or the
Esperanto prototype, which
might be Klege?
it might be. Well, I think they were all supposed to be on this. That's what also got confusing. Is like
Yeah.
what is Clesperanto? Which is a clever name. I love the name.
I do love the name.
Yeah.
We should have some like more detailed chats with others interested about this, because I don't think if you just rely on stuff and to like
Yeah.
keep it alive, it won't be
No,
successful.
but yeah,
It needs our involvement if you want it to be successful.
okay. Yeah, maybe we can.
I speak
Think
knowing
about it.
Stefan.
Oh.
He's a good guy, but I don't think he's the kind of person with his background and personality that's gonna like make this thing somehow go popular.
Yeah. Okay. I'll
But I
think
think
about it.
it could be
I
more
didn't do
that we try to steer it a bit.
It is soon or no.
Yeah, but I'm gonna sit here anyway. I
Okay.
was just curious to see if it was working.
It just seems like there's maybe
It's not a normal-
tension between Robert and him, which is why I was like,
Yeah,
It's
okay.
possible.
I
So
guess
worst
it's
case
just
scenario, we might need to.
I'll roll it. I'll roll it.
That's okay.
Yeah.
Yeah, I guess I actually was working with them a little bit just to
Stefan or Robert?
both of them, like just giving them prototypes and stuff that I had done. So I was doing wrapping of C code and
Nice,
everything.
nice.
So it seemed to be going pretty good, and then they sort of like went off to get this whole build system going, and then I haven't heard much.
Yeah, and then it was like that was like right around the time that he was a very early adopter of the LLM or the AI or whatever.
Right.
What is that? Biobob and
Yes.
stuff.
So he did. That's why I went to Dresden in 2023. Robert designed with some of the rest of us and designed like a really good GPU computing course for bioimage analysis. And it's like, it's too bad because he only did it once, but it was the kind of thing that would become really awesome if some people like did the course every year.
Mm-hmm. Oh no. Do you still want me to plug in?
No, it's okay. Seems to be working fine.
You're just like,
We can always swap it. The only thing is, I'm gonna have to. Can I do without the microphone, or is it because we're recording?
Yeah, it's
Yeah.
recorded. I think
So I have to find a way to use one hand and one.
we had an idea to put the microphone into the glass and it can stay.
yes.
So if you want,
I think it's fine. I'll try to work. Do we start immediately, or do we wait a couple more minutes?
I think you can start.
Okay. Well, all right. So, good morning, everyone. Welcome to the Navari tutorial. So, I'm Lorenzo. I'm one of the core team members of Napari. There's a few others here in the room that might go around and help you out if you need to fix some problem. And now it doesn't work. There you go. So there's a QR code here, and that's the link for the material for this workshop. Hopefully you managed to already go there beforehand and download and install. If not, it's fine. You can start doing it now. I'll give you a minute to get it started. If you go to setup and installation, you should be able to do everything there. Hopefully the internet is less slow today than it was the last couple of days. Shouldn't be too heavy, but you never know. There's a couple ways to install it. Choose whatever one you prefer. If you're undecided, I suggest UV. I'll leave the QR code on for a couple more minutes for everyone to get started and scan it and start downloading. If not, just let me know and I'll go back and you can scan it. I think everyone at least scanned it. All right, so while you start the installation, I'll just give a brief introduction on what Napari is, in case you stumbled in here and you have no idea, or if it's the first time that you're hearing about it. So Napari is, at the core, the idea is that it's a scientific image viewer for Python. And specifically, we try to follow a few general directions in its development. It is n-dimensional, which means any type of data of any dimensionality should be able to be visualized in NumPy. It is interactive, meaning that you should be able to, at any point, interact with your data through Python and through the graphical interface while doing the visualization. Tries to be as performant as possible, even with big data. Extensible. This is kind of one of the core things you will see during this tutorial. We want to be able to extend the functionality of NumPy with our own workflows as much as possible. And Pythonic, meaning we try to make things as intuitive as possible for someone who is familiar with Python. So core idea, you have an array, you want to visualize it. This is an example of a very beginner thing you could do with NumPy, which is just view some 3D data. Well, this is 4D technically, because this data comes from the sample data in scikit image, and it's 3D data plus a channel. There's 2 channels. And if you run this, I'm going to execute it. Let's see if it works. It should open NumPy. Drum roll. It doesn't. Wait. So it does run NumPy. You get something like this, and it's a 3D viewer. We're going to go through all of these things in a moment. But yeah, so you have multiple channels. There you go. Very, very brief introduction to that. We'll go through the graphical interface in a moment. All right, so what this tutorial is about. First of all, 1 second. Does anyone have any problems with the installation so far? Is it all good? All right, seems to be fine. So what this tutorial is trying to do is starting from our own little clunky Python script that does something, and we wanted to build an interactive distributable interface for the workflow. And we'll do this in 3 steps. We'll start from a pure Python function and build an interactive NumPy widget from that. We will build upon this concept to construct a whole segmentation pipeline starting from that widget. And at the end, we'll add a couple more things, see how that behaves in 3D, and if we have time, talk a bit about how to make that into a plugin. All right, so if you have everything set up, you should be able to do this now, which is the next step. We're going to look into what the NumPy interface is and how everything is, where everything is, I mean. So you should be able to launch NumPy, UV run NumPy if you installed it with UV. I think it's Pixie run NumPy if you installed it with Pixie. And then if you go to the section of the workshop on the website called Lightning Introduction to the NumPy GUI, there should be this button near the top. Because NumPy can just read remote data, and you can also read Python files as data, you can just drag and drop that button into the NumPy canvas, and magic should happen. I'm going to do that as well. I increased the size, but this is maybe bigger than I intended. But, well, hopefully you can read everything. Okay. Click this button. I will explain in a second. Okay, so this is my attempt at doing a presentation in NumPy. I hacked a bit the system. Okay, so if I click here first to select, press the arrow to the right. something happens. So you see here at the bottom, the arrow points to the dimension sliders. So these get populated automatically depending on the dimensionality of your data. In this case, we're looking at 3D data, but we're looking at it in 2D, so there's a third dimension to slice through. And this is how you do it. If you have more dimensions, more sliders will appear. You can see that I named this dimension slides, because this is a presentation, of course. But of course, that can be named however you want. Interestingly, if you right-click here, you get a feature that is not as discoverable, but you can, spoiler alert, there's some more stuff there. You can increase the thickness of the slice. So we're looking at more slices across that dimension. And they get projected depending on what's selected over there. And I'll get to that. If we move over to that corner, you have the viewer buttons. These are buttons that control general things about the viewer. So the button on the left here is the one that opens the IPython console. This is just a normal IPython console. It just is conveniently placed and has access to the viewer, and it allows you to interact via code with the data that is currently in the viewer. The next button is the button that toggles between 2D and 3D. This is really just a 3D set of data. These two buttons allow you to reorder dimensions in a certain way. We have the grid button. We will look at it more later, but essentially what it does is expands all of the layers into their own individual view box. And this is the one that I pressed earlier. It resets the view. So if I move it around, I can just... Whoop. What questions do you have about this part? Is everything clear? All right. So let's get to the meatier sides. So here you have the layer list and the layer buttons just above it. The layer buttons allow you to create new layers, the layers that are used for annotation. So they will be generated based on what you have selected in terms of dimensions and scales and transforms. And below here, you have the layer list. You can select layers. You can move them around, reorder them in certain ways. And this, of course, affects the rendering. And selecting it affects what is displayed up here. And that's because this next widget is the layer controls. And this is what allows you to actually affect the rendering of the currently selected layer. And you will see some stuff there that is probably familiar, like the opacity. If I do this, you see that the logo up there gets less opaque. And then depending on which layer you select, there's going to be a set of controls that are specific to that type of layer. So for example, if I select the points layer here, I can change the type of symbol used for the points, the color of the face of the points, and so on and so forth. I forgot to move ahead with this. All right, at the top left there, you have the menus. There's obviously all the stuff that you're familiar with up there. Importantly, some of these menus are contributable by plugins. So for example, if you open the layers menu and you go through, you will see a lot of empty menus. That's not because it's not implemented yet. It's because these are the places where plugins will add their own functionality. You also have some built-in stuff, like for example, if I go to the scale bar here in view scale bar and toggle scale bar visible, you will see the scale bar appears down here. And that is affected by the units, for example, that the layers are declaring. And if I zoom in and out, it changes. I'm guessing Curtis cannot see anything because I'm in the way, but it's fine. All right. One last thing before we move to the next is this shortcut is very useful, and I use it all the time. It's Ctrl-Shift-P. It opens the command palette. If you're using IDEs, you might be familiar with how this works, but essentially there's a bunch of commands, that actions that Napari can do. And when you do that, it pops up a widget that allows you to, let's see if I can do Ctrl-Shift-P with one hand. No, This way? Yes. You can search, if I search for axis, that's not axis. Why is it caps? There you go. I can toggle the axis, and then you see that we get those in view. And for example, the skill bar also will appear up there, and there's a bunch of other functionality, and those also are the same actions that you will see in the menus when contributed by plugins. Okay, that is all. Let me close up this. Okay, what questions do you have about this part? All right, then I think we are ready to get started. So if you now move on to the next section in the workshop material, we can get started with that section. And so this one is the one where we are going to start from a pure Python function and move on to adding that to Napari. Okay, unfortunately, the screen is not mirrored, so I have to look all the way there to make things work. All right, so this piece of code should be familiar if you're working with images in Python. It's quite small. Let's go through it. All right, so we're importing some stuff from scikit-image. Scikit-image is a library that just has a lot of functionality, a lot of functions for operating on images like segmentation and filtering and other kind of stuff like that. What we're doing here is we're just defining a pure Python function that takes our image as an input, some parameters, and does some operations on it. In this case, all we're doing is blurring it a bit to remove some of the high frequency noise, and then we threshold it, just a Boolean threshold, and return the blobs, right? So this is the kind of function you might write yourself to work on images when you're just doing your workflow in pure Python. So of course, once you have this function and you want to test it and play with your image, what you do is you just give it an image. In this case, we take one 2D slice from the data that you were looking at earlier, those that 3D plus channel data. We run the threshold, we pass some parameters, we just try them out, and we get out some stuff. Yes, I can. That good? All right. This scroll wheel is very aggressive. Okay. And we get out some outputs. So let's see how will we integrate this into our workflow with Napari, right? So we can do the same thing. Just run it. Then we spawn a viewer in Napari with napari.viewer. We can add an image with viewer.addImage. And then we threshold that image layer data. And we can then add a new image, which is the blobs we thresholded. So I forgot to mention this thing, which is important. All of these examples we're going through step by step. They have a script at the top. You can just drag and drop that, as we did earlier, into the Napari canvas, and it will execute the code that's in the script. You can, of course, look at the script, modify it. You can run it from the local copy that you have when you cloned the workflow repository. But we're looking at the entirety of the script here. So this code is the code in the script. So what you will see when we get here is this. Stay there. Maybe you should do the arrows. Yeah, maybe it's better. And of course, that's probably not what we want. We are just seeing a very high intensity something there. But now we want to interactively change those parameters and actually see how it affects our segmentation. So what do? Well, we can use Magic GUI, which is what Napari uses to generate a widget from a function. And if we go through the code and change just a couple of lines, we are now able to give this to Napari, create a widget automatically, and have an interactive tool that actually affects what the data, what the function parameters are. So as you can see here, we just changed a few lines. We have now as an input a layer instead of just the pure data. And we use type annotations because this is what Napari will inspect to decide what to give to the function. So now, because we are annotating with an Napari layers image, you will get the option on the widget to select which image will be the input, and Napari knows how to provide you those images. We also annotate the other ones, but those annotations have not changed. And we need to annotate the output type to tell Napari what to do with this output. So in this case, because we want to return multiple layers, we annotate it as a list of layer data tuples. And I'll get to why we do layer data tuples and not just layers. Of course, we need a guard. If there's no layer in the viewer, you will get an error. This is just there to avoid that error. This isn't changed. We still operate on the layer data. The return now is this layer data tuple. So this data tuple is a 3-tuple that contains some information about the layer. It's the data of the layer, the type of the layer here at the end, and in the middle, it's a dictionary of all of the other parameters that you want to pass to the layer. And you will see we will use some other parameters later. But for now, the thing we use is the name. And the reason why we pass the name is because if you pass the name and rerun the function, and there is a layer in the layer list that has that name, and it's the same type, then it will update that layer instead of creating a new layer. And this is very useful for interactive workflows. Is there something else below? No. Okay. What questions do you have about this part? No, that's why the Python files are there. So yeah, this workshop is more of a follow, click and drag, so you can see how the workflow evolves over time. You can of course feel free to modify these files and play with it, and I'll give you some time to do it. Yeah, for now, the idea is that you just can drag and drop those and see how these changes affect the output. And the arrow still doesn't work. All right. This I described. Of course, we're going to do the same thing as before, just add the data to the viewer. However, we have an extra line here. By doing viewer.window.add function widget, what we tell to Napari is, here's a function. It is annotated in a way that allows you to generate a widget from it. So what happens when you do that is you get a widget, surprise. And this widget has the drop-down that I was talking about earlier. This will let you choose which image layer to affect. or to draw data from. And you now get these little spin boxes to affect the sigma and the threshold, which allows you to modify the parameters. And then you can press run to execute it. And you will see that if you do that, it will update the data in the existing layer instead of creating a new layer. Okay, I'll give you a moment to play with this. And in the meantime, if anyone has questions, feel free. Yeah.
When you change something here in this widget, is there any like undo button or something like in the history of what you did? For example, go back.
So the question is whether there is an undo button for the operations done through this widget. The answer is no. We have some built-in functionality for undo for some stuff. It is a thing we want to have more globally, but it's not going to happen for this specific case. If you're, for example, painting labels, there is an undo button for that. Yeah. Is everything working for everyone? Does it make sense? Yes. The drag and drop doesn't work. Okay, Grzegorz can help you out with that. Can I collapse this thing on the side? Yeah. So this, if you're running the script, this is part of the script. This is already in the script. But if you're doing this from an IPython console, for example, you're defining a function, then you would take the viewer that you just instantiated here, and you're passing this. Okay, because you're just telling the viewer, hey, look, I have a function that I just defined. Threshold is the name of the function defined up there, if it wasn't clear. And then the viewer knows what to do with that function. Does that answer your question?
So one more question, because if we don't have this undo button, is there any button to rerun Napari again without, exiting it?
What do you mean rerun Napari? Yeah, of course. Yeah, so you can execute any code in the console that you have at the bottom. If you want, you can re-drag and drop a Python script in, and it's gonna work as you expect. If you launched Napari from a Jupyter notebook, for example, or from an IPython console, then the console button will be disabled, and instead you have to use whatever thing you ran it from. And it is interactive, like it's not going to block the GUI or vice versa. So you are able to just re-add it. Like if you now open the console and redo this, like run this command, it will re-add. It will probably add another copy of the widget. Yes.
I have a visualization question. So we have these three layers, right? One of them is a binary mask. The other two are versions of our data, right? The blurred data and the original data. And so, and of course, the binary mask, the way that it's been naively configured, which is just like, throw this stuff in the viewer. We only see the binary mask. We can't see the other images, right? So what I'm wondering is, okay, I played with the blending mode, and I changed things to additive, and I use different colors, right? This is the typical way you view this. It's like I want to see my mask is like green, and I want to see the data as say magenta. So the question is, though, because you have two versions of the data, how would you set the blending so that I can quickly toggle between the blurred and the original while always seeing like the mask. You see what I mean?
Yeah, I see. So the question is how would you play with the blending of the layers in a way that allows you to quickly toggle with just one button press, for example, the whether you're viewing or like the threshold blobs over one version of the data versus the other. I think what I would do is just toggle the visibility, and yeah. Yes. Yep. So let me. Whoop. Where's the mouse? There you go. Yeah. Right. So I didn't mention this. I should have when I was talking about the layer list. But you have the visibility button here. You can toggle a layer visibility by clicking on it, and this is a very quick way to hide one from view. Another thing that I was gonna get to later, but I'm gonna get to it now since you're asking, is the grid mode. So this is where it's actually gonna come in handy. If you press the grid button, which is the one here at the bottom left with the 9 squares, if you press that one, the canvas will switch to grid mode, and that places each layer in a separate view box. And while you don't get the overlapping data anymore, what you can see is the whole step-by-step workflow side by side. And this is another way that I find useful to do this kind of stuff. Yeah. And if you zoom in and move the camera, they are all synced in the grid mode. So that allows you to actually zoom in into a specific detail and see how it looks in various steps. Any more questions about this? Tim? I think for the recording, it would be nice to use that's why I'm repeating questions.
I just don't want to steal all your thunder. Okay. So there's some other ways that you can play with this. One of the recommendations we have is this blending mode here. And when you have multiple layers and want to see what's underneath, the default is translucent, no depth. And what that does is actually blocks the rendering of everything underneath it. You can change this to additive though, and then the layers will kind of like stack up visually. In this case though, you still would have this like white kind of overwhelming the image. So one of the ways that I play with it actually is the opacity slider. If I'm ever want to mess around and not toggle the visibility totally on and off, you can change the opacity to something like 50%, and then you'll see what's underneath it come through. And indeed, if you make a labels layer by default, I think the opacity is 70%. So we kind of like use those tools.
Thanks.
That's the main answer to my question is that you just change blobs to additive.
Yes. Sorry. Yeah, I forgot about the blending part of it. Yes.
Visibility of the blurred image, you can watch it get blurred and unblurred.
Yes. Got it. Yeah. Okay. So the next step is making this interactive widget actually interactive, because right now it's kind of tedious. You have to press buttons or type numbers and then press run. But we want sliders. Sliders are fun. So that's actually a pretty simple change. We need to put an annotation that is a bit beefier. And this uses a relatively recent typing update from Python, from the typing module, which is annotated. And by doing annotated, you can pass a type, but also some extra metadata to that type. And the metadata is a dictionary, which has some information that Magic GUI knows what to do with. And in this case, we just say, hey, give us a slider. This is the minimum value, maximum value. And I want this step between each point on the slider. Nothing else was changed, except this line. Is it highlighted? This should be highlighted. Except this line, which passes an extra keyword argument to the add function widget. And in this case, we say, hey, please autocall this function. And what this does is it removes the run button. And now every time the sliders are changed, it automatically launches the function. Of course, this shouldn't be done for stuff that is extremely heavy in computation, otherwise it will kill your performance. But otherwise, this is very useful for these relatively lightweight operations. So when you run that, if you drag and drop the next script, you're going to get this. And this looks a lot more like the kind of stuff you actually want to be playing with interactively. I'll let you play with it and ask any questions about it. Clear everything in what sense? Remove the layers? No, we don't have a command to like reset to empty. That would be nice. I agree. You can close the widgets. There's a cross in the widget on the top left. So you can close any widget. And for the layers, you can select all layers by either doing shift click like you would expect in a like a browser, or Control A to select all when you're after clicking on it. And then you can either, I think, press delete or press the this button here, which is the delete button, and then you can delete all the layers. If everything is clear, we can move on to the next section. All right, we know how to do an interactive widget. We have all of the components. Now let's stick more functions into it. Let's make it more complex. Let's actually build a pipeline. All right, we have our thresholding. Now we want to add a couple new parameters and actually extract features from this data. So we're going to use a couple more functions from scikit-image. We add 2 lines that look very similar to the 2 lines that we had before. It's just 2 more sliders, but this time they are to control the minimum hole size and the maximum and the minimum object size, which are used by the function that extracts, well, they're used by the functions to clean up the data before we extract features from the image. And these are those 2 functions. It's not that important how they work, but we're going to get to how they behave in a moment. Tim? What options I'm doing in? Yes. Yeah, you can go to the Magic GUI documentation. I don't know to what extent we have documentation about this on Apari. We do have some page about Magic GUI, but they point to the Magic GUI documentation, which is, let's see if I can get it. Well, that was easy. And here you can find a list of all the widgets somewhere, all the... Yeah, I just cannot read anything from this side. Yeah, I won't go through this documentation, but this is where you find all the details. And there's a bunch of different widget types. Most of them will be automatically selected depending on what you provide. Like if you provide an enum, it will know to give you a drop down. But for stuff like a float, then sometimes what you want is really a spin box, sometimes what you want is really a slider. So it will try its best to guess the correct thing. So yeah, so we're running on our blobs, the thresholded blobs. We're running remove small holes and remove small objects. This way we can clean up the data from all of those little specks before we actually do the heavy lift here, which is the measure label. And we pass in the clean data. And what we get out is another array. And this time, instead of being a Boolean array like the one we were getting before, the blobs, what we get is an integer array that has a different integer for every individual feature that is like non-contiguous in the data. We have to, of course, add these new layers to our return. I mean, this is the way I chose it. Of course, you don't have to have all of the intermediate steps, but we like to have the intermediate steps because we can then look at what went wrong and how our sliders affect each specific step in the workflow. And everything else is unchanged. And what you get looks something more like this. And this is the point where I would definitely suggest to use the grid mode to have everything side by side so you can see what each step in the workflow does. Was there a question there? No? Okay. So I'll give you a moment to play with this. And of course, you can toggle the visibility of layers to see, to hide some of the steps. Unfortunately, if you're in grid mode right now and you toggle one layer, you just get an empty box there, but not for long. We had a contribution just now at the sprints that will soon be merged. What questions do you have about this part? Yep.
If you move the slider, does it calculate, like do the calculation at every like increment as you move it, or is there like a way to make it like only do it when you release the mouse?
I'm not sure if we have a way, an exposed way to do that. I'm pretty sure Magic GUI can do it. Yeah, I don't think we have like a, unless maybe one of those keyword arguments, like when we passed here, the magic quarks, there might be one here that you can pass that does that, but I'm not sure. But yeah, if it starts being too heavy, then that's the point where I would say probably either the slider is not the right way to do it, or I would move to the run button. Any more questions? Yeah.
So, is there any way to probably as just an idea I had is like if you wanted to make like multiple different routines, is there any way to like add them to the same side panel? So like if I had 5 different segmentation routines, each of them was one of these little GUIs, but I didn't want like 5 side panels. Is there a way to have like a combo on your GUI and then like choose which one you want to use?
I'm not sure I understand the question. What do you mean, like a combo?
Like say you had 5 different patterns or 5 different like workflows that is there a way to like have like a combo that says which recipe to use? Then each recipe is like a magic function that you choose, so you could like update.
So you want to compose different widgets into a pipeline? Is that what you're saying?
Not compose into a pipeline, to be able to choose between them on the same like side.
You can. So one thing you can do is you can have multiple widgets there, and instead of having them one below the other, you can have them tabbed. If does that answer your question?
That would be one way to do it.
Yeah, you can do that, and there is an API through the add widget. There's some keyword argument there that allows you to put it in as tabbed, I think. And if there is, yes, they confirm from the direction. So yeah, that's the way you would do it, and I have seen it done in many widgets. Of course, it like when it starts getting more complicated. For example, if you want to have what you do in a tab influence what's going to happen in another section or in another widget, then for now the way that you would do that is you create your own widget, and then you can pass to Napari a Qt widget that is pre-built, which could be partly or fully made from Magic GUI components, or it could just be pure Qt. And then it's your responsibility, let's say, to do those connections.
So I assume there's also some way to just get the like widget, and then like say you want instead of a tab, you want it to be something else, you can like get the widget programmatically and then put it wherever you want.
Yes, there is a way to get the widget programmatically, like a doc widget that was added. I don't remember right now where it is. I think it's viewer.window.docWidgets or something like that. Okay, I think we can move to the next step. So now we're gonna add some other function, and what we want to know is now some quantitative information about the features that we have extracted. I just realized one important thing that I have not mentioned here is that one new thing we did here was use the labels layer, right? So earlier we were only working with images, but now what we did is add labels. And when we add labels, what we get is this colorful layer, and it has a bunch of different functions here. You can also interactively paint on it, and it is designed to work with this segmentation data where each blob that has each pixel that has a different integer value will be interpreted as a different feature. So now at the next step, what we're going to do is add some computation about some quantitative information on these features. We don't need to add anything in the inputs. The only thing we're going to do is add a few lines here and then return some more layers. What we're doing here is using measure region props table from, again, scikit-image, and we ask for a few specific properties. We want to calculate, well, we want to know the index of the label. That's always useful. And then we want to calculate the area and the centroid of these labels. The area is actually the n-dimensional area. So in 3D, it's going to be volume, for example. We also set the index of this data frame, because this is a data frame. We set it to the label index. This is useful because then we're going to pass it to the labels layers as a properties table, a features table, sorry. And also we want to calculate the centroid, compose the centroids, because we get a separate centroid for each dimension. We just compose them together and name it, so that when we add it to the pandas data frame, it's easier to know what that centroid means. And what we do is we update this line that we had before. And now, as you can see, instead of only passing the name, as we said before, what we do, we also pass the features keyword argument. And the features keyword argument allows you to pass a data frame that contains some extra information about each element in that layer. This is supported by a few layers, a few layer types. The labels layer supports it, but also the points layer supports it. The surface almost supports it. And I think the vectors also support it. Basically, those layers that have a concept of individual elements inside. So this is just a normal pandas data frame that has the same length as the number of elements that are inside the layer. And we pass it both to the labels layer that we created earlier, but we also now make a new points layer that has the same features just for convenience. And we will see how that looks like in a moment. Oop. So now we have points as well. And you will see one thing that I haven't mentioned until now, but depending on which layer you have selected, if you hover over something on the canvas, at the bottom left of the viewer, down here, where now it says just ready, it will actually have some information about that point in space where you are at the moment. So if you have the points layer selected and you hover over a point, it will tell you the ID of that point, and it will also have a list printing out all of the features for that specific point, if there is a features table. So right now you should be able to hover over a point or hover over a label if the labels are selected, and it will tell you down there what the area is, for example, or information about the what was the other thing we did? Yeah, the centroid. What questions are there about this? Yes.
Can you color the cells by area, for example? Like, is there a way to do that in a GUI?
In the GUI, no. Draga has something to say. So, yeah, sorry. The question was if there is a way to color the labels based on the area, for example, or based on a feature in the features table, on a column in the feature table, and there is a way to do this for points. There is no way to do this for anything from the GUI at the moment. You have to do it programmatically. I don't think you can do it for labels at the moment from the features. You can do it yourself. You can color map it and pass a dictionary of colors, and that will work. But the current implementation of the features for labels is incomplete. We are planning to do that and unify it so that it works in the same way as it does for points and for shapes. Shapes I didn't mention earlier. That's another one that, yeah. And please correct me if I'm wrong, the others, because I don't remember. Yeah, okay. But the way you would do it programmatically is if you do, if you have your layer object, let's say it's called labels, and you do labels dot color equal the name of the column, then Apari knows that because you passed a thing that is in the features table, it should color it based on that. And the way it colors it is based on layer dot color map. And the color map, you should go read the documentation about it. There's many different ways that you can do it, but it could just be, Viridis or Magma or something like that. And then it will color it based on that. But not for the labels yet, unfortunately. But if you do that with the points, it will work, and we'll look at it later. Yes, the question is, can you also add the size of the points? The answer is yes, and we will look at that later. So this is actually the point where I would have suggested to do the grid mode, but I guess I should move it up to an earlier point. Any more questions? The question is, can you make a selection of which layers you want to display in the grid mode? So depending on what you mean, there's two answers. If what you mean is I only want to display some layers and some I want to not be there at all, then the answer is soon, probably in a couple of days, because of the contribution we got at the sprints. Because then if you just make it not visible, that box will disappear. And this is, I know, a thing that a lot of people want. If the question is, can I choose where they go? The answer is, we have the stride. One thing I haven't gone into details earlier, but you can right-click on a lot of stuff on the GUI, especially if there is this little triangle on the bottom right. That means you can right-click that, and there's some extra features there. And if you right-click on the grid button, you get a menu that allows you to change the size, the shape of the grid. And one of the things you change is a stride. If you change the stride of the grid, what that means is that many layers will be put in each view box. So if the stride is 2, then the first 2 layers go in the first view box, then the next 2 layers go in the next, and so on. This is very useful if you are, for example, doing annotation on multiple layers and you want to see each layer with its own annotation in its own view box. However, then you have to order them alternating for it to work in the layer list. To do the full-fledged thing, which is I just want to put these 3 layers there and these 2 layers here and nothing there, for example, that is in progress. We are working on it, and we know that there's a lot of people who want it. Any more questions on this part or anything else that came before? Okay, I'm gonna move to the next thing. Yeah, here there's a little snippet of code that you can run yourself if you would like. If you copy paste this into the console at the bottom, you can see how this kind of stuff can be accessed also programmatically, the overlays that I talked about earlier, because things are starting to get a bit confusing now with all these layers, and to know exactly which layer is which, what you can do is you can enable the layer name overlay. This also can be done through the command palette. If you select all layers and then command palette and search layer name overlay, then this will pop up. But you can also do it from the command line. You can enable the grid, you can enable the visibility of the layer name overlay. And what you will get is something like this. You now have the name of which layer is in which viewbox. And if you play with the stride, you will see that now it will tell you which, like they will collapse into whatever viewbox the layer that it refers to is. Did anyone have troubles with opening the console and running stuff in there? Or any questions about this? Okay, let's move on to the next step. We're now going to do a bit of a refinement step. So unless you found amazing parameters, what you might have up here in your result is that in some cases, some blobs that are too close to each other are being grouped into a single feature, and so they have the same color. This is not what you want ultimately, because we want to be able to select a single cell and know what to do with that one cell. So sometimes what we want is to be able to do a little manual intervention. So that's what we're going to add now. We're going to add a manual intervention that allows us to say, okay, no, look, these two features are actually two different features. There's, of course, ways to do something like this also in automated ways, but this is what we're looking at now. And often this is it saves you a lot of time in creating complicated automations for just a small thing that can be done manually very easily. So because this is going to be a manual thing, we just add a new widget. So it's a whole new function, and it's going to be added side by side to the other widget. So we are importing some new stuff, again, this time also from SciPy and the image. Again, this is untouched. It's the same function as before, but we are creating a whole new function here. So this is the watershed algorithm, and what it does is it takes some inputs that are points that are inside individual features that you provide, and then it will expand out of that following the gradient of the image, and it will find the connection points between it will expand until the middle point essentially between two different features. And so for that we have to pass in the markers, and now you see that we're passing another type of layer. So we say points. This way Napari knows to pass the points instead of the images, and as the other input we want labels. Again, we have a guard to make sure that nothing explodes, and the rest is essentially running wait, sorry, what is this again? I have to step back. Yeah, we have to compute the distance field, and that's the thing that we pass in to the watershed. I won't go into details on how the watershed works, but you can look it up on the scikit image and SciPy documentation. The next step is we take the markers that we passed as an input, and from that we need to do some processing in order to generate the markers, which are the seed points for this watershed that I was talking about. We cannot just pass in coordinates. And the last step is to actually run the watershed algorithm, which takes this distance field, the markers, and the mask. And the mask is the original labels that contain the information about the features that are not yet separated, let's say. The distance field instead is computed from the original image. The return should look familiar at this point. It's the same thing that we have done before. We just pass a name and then the layer type and the data. So now we have to add another line here that adds another widget. We will not pass autocall at this point because this is we want it only to run once we have cleaned up and selected the right parameters. And if potentially it can be very expensive if we run it at earlier points where there's a million labels because we haven't found yet the correct parameters. And if you run that code, you will get a new widget below. This is a bug that needs to be solved, that the widget goes all the way down here, but you can drag it up if you want. You can see these gradients here. These are the distance field that we computed during that image. One thing that you have to do in order to use this is once you have run the first widget and found the labels as nicely as you can, you should create a new points layer in order to then create the seeds that you will pass into the into the watershed algorithm. If you don't, it will automatically populate this. Well, it will anyways do it, but it will automatically populate this with the first points layer that it finds, which is right now the points layer that is generated from the features. So nothing different will change because you will use as the seeds for the watershed the centroids of the features, which already are in the feature, and there's only one per feature. So you will see that if you just run this with the default input, it will just create a thing that is a copy of the labels that you had before. So you should create a new points layer, and you do it by selecting any layer here. It will inherit the transforms from it. In this case, there's no transforms, so it doesn't matter. And you click the first button on the left. That's the points layer. Once the points layer is created, you will have, and I should have changed here the selection, but you will have up here a few buttons. Those are the layer modes. And there is one with a plus. You can change to that, and that allows you to add points. Once you are in that mode, if you click on the canvas, you can add points to the position that you're clicking. So you should click through a few and then run and see what happens. Of course, the ones that you didn't click on will not be populated in the last clean set of labels. And I'll let you play with this for a moment, and feel free to ask any questions about this as well. Any troubles with creating points? Did you manage to get a final segmentation that looks like you would expect? There's no fused blobs. Who did it? Raise of hands. Who has clean blobs? We have 1, 2. All right. Oh, lots of people. Almost everyone. Did you not get it? Are you having troubles with something earlier on? Okay. Yeah. No worries. I'll give you a couple more minutes. So the question, continue, sorry. So you're asking, this gets only executed once you start moving the sliders, and it does not run it automatically at the beginning. That's what you're saying, yeah. So that's because the first callback happens only when you move the slider. However, that doesn't have to be the case. The thing that we passed in to Napari is just function. It is a function that has a lot of stuff attached to it, which makes it into be able to add it as a graphical interface, but it is a function. So what you can do is once you added it to Napari, it's added to Napari, the inputs get populated, it automatically selects an image layer. So now if in the console you run, I forgot the name, it's like threshold and label, and you just execute it as a function, it will execute it with the current inputs from here, if there's any inputs that are selected. And I thought I did that in the code, but I guess either I didn't do it or it doesn't work anymore, but it should work. But yeah, the magic GUI annotated function is actually a pretty. No, I know why. It's because you have to get the actually generated magic GUI, the function that is already decorated by the magic GUI decorator, which is what happens behind the scenes in Napari. So right now what we're doing is we're passing in a function, and then Napari takes care of the magic, right? But what you can do is you can import magic GUI, use the magic GUI decorator to decorate the function when you define it, and then it already is a magical function. And then you can pass that to Napari, and Napari will know what to do with that. So in the code here, where we do add function widget, what you can do is you can just pass add doc widget. And when you do add doc widget, what Napari expects is something that is either a Qt widget or something that is already a magic GUI thing. Okay, so you can do it yourself, and in that case, you already have it, and you can call it in whatever way you want. Another thing you can do is you add it to Napari from code as a function normally, and then you grab it back like it was asked earlier. You can do viewer.window.docWidgets, and you can get it back. And the thing that you get back is the augmented one that is now like magic GUI. This is my computer actually. Oh, it was charging. What happened? I think it died. Oops. Yeah,
So I actually think I just gave a workshop at SciPy, and what you just asked came up because it almost feels like a bug when you add it and it doesn't do anything, and you have to slide it because you're like, I set those values. So I think I'm going to look into it at the hackathon and see if maybe we can think about it, maybe an auto run for like the first one or something. I think something maybe Lorenzo hasn't said that I think is really cool. He's mentioned that you can get this like function or widget back out. So if you're working in like a Jupyter notebook and you pass this decorated widget to it and it's in the GUI, right? And every one of your arguments then becomes an object on the function that you have. So if like the object was image, you can do function.image and it will let you see the properties of it. So you could, if you were in a Jupyter notebook, go function.image.value, and it would print out to you that value that you have in the viewer. So you could save for the future what parameters you did. So you could print all the values out of the widget. It also means that programmatically you can pass values to the widget. So from the Jupyter notebook, you could do viewer.min whole size or whatever the value is, and set it from the Jupyter notebook, and that will actually update the widget in Napari and automatically run it. So you can talk between like a notebook and the widgets. So while they're going, does anyone have any other questions? Sure. Yeah. Uh-huh. Mm-hmm. Yeah, so the question is about like, what do widgets see of each other? The answer is the widgets see only what they're provided with. So unfortunately, that means something that you do in one widget does not affect anything about the other widget unless, for example, widget one, whoa, it's really raining outside. Widget one might output like the blurred image, for example. And if widget two is reading the blurred image and thresholding it, like if that was your two widgets, right? One took A to B and then one was B to C. Then when B gets output as different, that value updates in the second widget, and so it would auto run. So if they're intrinsically connected via their arguments, like the layers, they would be connected. If you want to start really connecting widgets, though, you do what Lorenzo was talking about, which is you build these bigger widgets where they're in. One way to think about it is a container. They're all in the same container and they share the viewer object, which means that anything that's happening in the viewer, including from one widget to another, you can pass. So you start to kind of use object-oriented, a class to manage a state. But it's all, unfortunately, right now, basically the point is that you have to manage the state. We have a lot of discussions, though, about how can we figure out like a model to share state between different widgets. It's probably been asked for since the very beginning of widgets, and it's something that's really, really kind of difficult. But we do hope to solve that. Yeah. One of the things that Lorenzo didn't show, there was kind of this question about undo earlier, and it's correct. We don't have undo. If you have a magic GUI function, in all of the examples, Lorenzo has added the title keyword, which is like what you would pass to viewer.addImage, and that gives that layer that keyword, which means every time this gets output, it will update the named layer in place. If you don't name your output layer, each time you run a function, you will get a new layer, which means if you're doing auto run, you have to be really careful because you could really quickly add a lot of layers. But if you have a widget that has like a run button, then you could get a new layer each time. And that's often what I do. And then I kind of like click through and inspect, like, okay, I have it maybe, or even you can say the title, you can use an F string and like say what were the values in that, right? So you know that it's, a Gaussian of 5 versus a Gaussian of 10, and then you can kind of get that visual information.
I think we need to get someone I see the string, but it doesn't.
Any other questions? Trying to think of one earlier that I had more input about. Yeah. 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 So the question is about, can we take what we do in the viewer and kind of run that again on multiple things? Right now, that is not something that Napari itself has magic for. And unfortunately, this means that people have reinvented this wheel multiple times, including myself. We were having this discussion yesterday amongst like who was around the table even. One of the routes that we might take is in that command palette, you can search for any action, and plugins provide all of these actions as well with their functions. So we would hope to maybe track some of that history. If you've used ImageJ, Fiji before, this is like, I think, really core functionality. So that would be one way of looking at it. Whoa. But no, not easily. So some people output their like metadata to like a JSON and then reload it in their thing. I've spit mine out into a YAML, and then it reads that YAML on the next run, but then you have some kind of batch stuff. I don't think any of these are perfect solutions either. I know this is something Brian is really interested about. So yeah, it's a really commonly asked question. And I think for anybody that has questions like that, I don't think Lorenzo brought it up yet. Our socials, I'll kind of brag about our community. Napari.zulipchat.com is one of the best ways to get in touch with us because us nerds are like global. So like someone will be awake and usually respond to you pretty much within an hour or two, if not faster. And we love these kind of discussions when you have them in your head and we hear them at workshops. We know that that's what people want. But when they start to show up on our Zulip and people kind of dogpile on that, it really gives us that extra push to prioritize things. There's a lot of things we want to do. The other thing that we invite everybody to do, every single person in this room, we would love you to contribute to our community. So even if you just have an example of your data, we've been really expanding our example gallery lately. We'd love to work with you on that. One of the reasons for that is because you can get our kind of like expertise on Napari, and then we can get your cool data and you to be closer to us, and that's really fun for us. So examples are a good way. Documentation. We have regular community meetings. We usually have about 2 every week, but they're in global time zones, so something will fit you. If you go to napari.org / oh man, it's not a good one. I think it's called meeting schedule. But if you type in Napari calendar, you'll find it. If you go to napari.org, there's this row of really handy links. It shows the Zulip chat. It shows the calendar, which we meet on Zoom. And of course, it can take you to our GitHub and stuff. And then like we do use socials like we're on Blue Sky and LinkedIn and stuff, which does reach a lot of people, but we're not as active as we should be on them. I don't think I missed the socials there, but yes, we really love. Our favorite thing is that this really does feel like a community project, and that's important to us. So I didn't. Thank you, Curtis. So forum.imagesc is like one of the, if not the premier place to go to learn about bioimage analysis and other image analyses that we've had a lot of material science and kind of some of those questions over time. That's a really good resource to ask any question. And I really want to promote forum.imagesc because with LLMs, it's really easy to ask your question to the LLM. It's way more. You will learn way more if you ask it on forum.imagesc. I promise you. Especially because folks like Curtis and Brian really show up and dig into what you have to ask. So, and the Napari team does too if it's Napari specific as well. We try, but especially if you have a general question, like I know I was talking to Sebastian and Selena, and they're trying to look at plant phenotyping, and they're at the stage of like, what tools do we even want to use? The forum.imagesc is the best place to ask those kind of questions because people will show you things they might know, things that have worked in ImageJ or Cell Profiler, maybe in Napari. And it's, I wish when I was a graduate student, especially, that I asked more questions. And I still wish that today. I wish I asked more questions. So, yeah. And we're back. There you go. Your special interruption with Tim is over.
Well, thanks, Tim, for filling that space with useful stuff. Okay, so we're back. Hopefully, you also learned some stuff in the meantime and had some time to play with things. So, any questions about this part that might have popped up in the meantime? All right, looks like we're good. So, go for it. No, that's why there's a drop down. You can choose. That's why also I was saying by default, because it initially there's going to be 1 points layer that's generated by the first widget, it will select that automatically because it's the first one that shows up. So once you create your new points layer and you start clicking around to as a seed, you actually have to go there and say, hey, please use that points layer now. So you just get a drop down with all the points layer. Essentially, what the annotation means to Napari is give me an option to choose any of these. I thought you had a question. I saw something move on the left. All right. Okay, so let's look at the last step. What time is it? Oh, we're almost done. All right. Then let's go through this one a bit quicker. Okay, so for this last step, what we want to do is do some classification and look at stuff like we said earlier, the rendering based on the features. So what we're doing here is we are also returning an image layer from the, wait, hold on, where are we here? Yes. from the watershed. So this is from the second function that we were playing with. Oh no, there you go. Did I copy paste this wrong? Yeah. Okay, the main function that we're looking at here is the classify features. Am I actually mirrored? Yes. Okay. So what we do here is we take the centroids as an input again, right? And we want to try to actually compute some other features from the annotation that we did before, from the labels, right? So we're using again the same logic as before. It's the region props table. We just added some stuff here. We added the solidity, and we added the mean intensity. In order to do that, however, to compute these kind of features, we have to pass also the intensity image. Because earlier we were only working on the labels. Now we want to know something about the original image inside those labels. So we pass both those things, and that's why we added the image input here in the watershed function. So what we do here is we compute these functions, these features, and then we pass it to the centroids as, this is hard to use with such a big zoom, as features. So this is the same thing that we used before. It's just a pandas data frame. We dump it into the points layer, yes, and we will have access to those features. However, the points layer actually is set up to be able to do the rendering and the color mapping and those things based on those features, like we were talking about earlier. We also added another function here, and this function takes those centroids that we hopefully generated earlier from the other function, and it allows us to tweak the parameters that we use to do the rendering and the color mapping. I called it classify here because we're essentially separating them in different classes based on whether they match the thresholds that we give it. So you can look at this more in detail later, but the general idea here is that we use that solidity information, which refers to the object that that centroid refers to, and the mean intensity, in order to color map the border and the face of the points. And for that, of course, we have to pass in some color maps, like we said earlier. So you see here that when I pass the color map, I just say a string, and that's because Napari has the logic to know that if you pass orange, what you mean, oh, map from black to orange, or map from black to cyan, based on the range of values in that feature. So we map the border based on the solidity, and we map the face based on the mean intensity. We have to do some rescaling, some normalization. And then here we compute good, which is just basically a Boolean operation on whether the solidity is within some thresholds and whether the rescaled mean intensity is within some thresholds. And those thresholds are passed in here at the top, okay? And this time you will see that it looks similar to before, but actually we have a tuple as the annotation for our sliders. And here we use float range slider. And this is a slider that has two handles, and it allows us to select a range between two values to, for example, select all the values that are between those two. And we compute this good property, and we add it to the features as a column. So now the features table will have a new column that is called good, and anything that is good, we set its symbol to diamond. Otherwise, it's a normal disk, which is the default circular thing in the points layer. We add this new function widget, again with a autocall true. And what we get is something like this. Oh, I think I forgot to mention something, which is the size. There you go. So we currently don't have yet implemented mapping features to sizes directly. So right now what we're doing is just pre-computing the sizes based on the area of the original, the area which is like the size of the label essentially. So the point size is going to be proportional to the size of the label that it's referring to. This is of course just, I don't think it has a great utility, but it's just a showcase of what you can do. So what you can get here at the end is this. We have an extra, oh, something went wrong here. Does it look like this for you as well? The sliders, do they look ugly? Or do they look more like this? Okay, so they are ugly on yours? Yeah. I saw this box somewhere and I think I opened the PR, but I thought they looked fine here. Well, this is to be solved. They don't inherit the style. So yeah, so basically, depending on how you move these now, you will be able to determine which of these features are good or not good based on which ones become diamond, essentially. And this should also all work interactively. And at the same time, the color mapping on the inside, the face of the point, and the outside, the border of the point, will also be affected from those thresholds. I'll let you play with it. Of course, here you have to select, as we were saying earlier, the correct points layer, because otherwise it will not have the features that you want. The previous ones don't have all of these features. They don't have the good feature. All right, since we're basically done, I will super quickly go to the last step, which is going 3D. And the fun thing is that everything we did works in 3D. You don't have to do anything. So the only thing that changes in the last script is this line. Oops, I highlighted the wrong one. Well, it's this line. We just pass the whole 3D data instead of only at one single 2D slice. And you will see now that the importance of removing small objects and small holes, as well as looking at the data in 3D while you're doing the thresholding, actually comes into play. Because earlier it was pretty simple getting the correct values. Now once you're at this point, you're going to be happy that you have this nice interactive workflow, because there's many points where you might have to go back and change something in order to improve the behavior. Of course, this is probably a lot slower to run. So be careful about running the lower parts willy-nilly. It should be fine on most modern laptops. But okay, I'll let you play a second with this. We maybe take 2 more minutes. What questions do you have about this? Of course, this is, I said you get 3D for free here, but actually you get ND for free. This code will work on higher dimensions. What that means exactly, that's a different question. But well, if you were to add a 4-dimensional dataset here, you would have the 3D view plus a slider. The problem is the code will work in 4D, right? We have talked about this before. Currently, there is no way to say only work on 3 dimensions and then operate on every time step. For example, if you have a time, you would have to add that logic into your widget. Right now, if you run it, it will find the 4-dimensional centroid of the 4-dimensional feature. And that's a different thing. Most things do in scikit image. I didn't test this one for the, just to be clear. Okay. If it doesn't, it's not Napari's fault. That's what I'm trying to say. No, jokes apart, it's like you can do it. You just need to have your code be able to run on n dimensions.
If you want to get the current step size, current step, like the position of your sliders into your function, how do you do that?
So you can access, the question is, how can you get the current step if you have a slider at the bottom in your functions in the widget? So there is another annotation you can pass to your function, and that's the viewer. If you annotate an argument of your function with napari.viewer, the viewer will be passed into your function, and you can get anything from there. Yeah, in general, you want to, as much as possible, avoid you doing this in order to mess up with the viewer too much, because it might conflict with other widgets. But getting information or setting state is a thing that I do all the time through functions like this. And the way you would get this, the current step, is from viewer.dims.currentStep. Current step is actually an integer, so it's less interesting, I guess. But what you can get is also point, and that is like a floating, like it's a n-dimensional point in world coordinates that is describing the actual point where that we're looking at.
So the current step is a list, right, of all the positions.
I think so. It's a tuple probably, but yeah.
So then if you're just looking to index something, you still have the current, even if it's an integer, you have what you need to like index. You want the current steps, you want to get 4D, and you want to get the current 3D.
If you have no transforms, yes. The question is whether you can use the current step to just index into the data, basically. Yes. So that's why I mentioned the point, because the point actually is describing the point in real space. So if you have transforms, that probably has a more physical meaning. But if you translate your data, then the position of the slider is not equivalent to the index at which in the data you would get the same data that is currently visualized. All right, I'm gonna close up because I think we're out of time. We didn't have time to get into the plugin business. What you can do is look up the Napari plugin template is linked in this page. It's very simple to get the template started. It uses copier. It's all explained into the README of the template. It sets up a Git repository and a Python package that is almost ready to go. And basically the only thing you have to do is plop your function. All of the things that we did up here, we can plop them in there. And then there's a small file called the napari.yaml where you can just point to those functions to tell Napari those functions are commands and do something with it. I do have on my GitHub a version of this workshop turned into a plugin. I forgot to update it to the newer version and then link it, but I can point you to it if you want, so that you can see the kind of changes that you need to do, which are very minimal. It's really just copy paste this file and then add a few lines in napari.yaml, and that's a plugin. You can publish it or not, and you can just give it to people, installing with pip, and then all of these functions that we have seen now, all of these widgets will actually appear in the command palette, for example. You can just search for watershed and it will pop up, and then you can put it in. Okay, oh, damn, we're on a different computer, so I don't have the finishing slide. Well, let me see. No, but it's not gonna plug like the problem. You think it's fixed? Yeah.
The problem was with our system. Working.
Yeah.
No. No.
No, I don't even see it. Well, sorry about that. I have some links there. You can just come up to me. I'll show you the links. But main thing to keep in mind is napari.org. You find basically everything there. Also links pointing to the calendar where you can find the community meetings that I think Tim already talked about earlier. And definitely come on Zulip. Zulip is the chat we use to talk about all of this stuff, and we are very active there, and it's very informal. You can just show up, ask a question, and it's very easy to get feedback on anything. All right. Well, thanks for coming to the workshop. I didn't get it, sorry. Yes, I will do that.
Okay, so hi everybody. This tutorial is going to be an introduction, so no skills are needed. It's going to be just basic stuff. If you want the materials, they are going to be on a GitHub. So I will show it to you when we are going to start using them. So first, I will do small presentation, and then I will give you all the tutorials. Okay, so my name is Justyna Szydlowska-Samsel. I work as research assistant at University of Szczecin, and this tutorial is basic tutorial, but it is about very important skills. So when we talk about the data science, we also need to talk about the efficiency, and this is going to be the main difference between the pandas and polars. So here we will go through the basics of these two libraries in a context of also a basic data science workflow. So first, I will do very short overview of Python data science ecosystem. I suppose most of you already know most of things. Then when it comes to decode, we'll do basic stuff. So loading data sets, inspecting data structures, cleaning data, selecting, filtering, transforming. Basic aggregation for sure, computing summary statistics. I'm not sure if I added it at the end, but it's also one function, so we can also do that. And brief comparison of pandas and polars. So, what is data science? If you would like to compose the definition, data science combines programming, statistics, and domain knowledge. This is the three things that we need to extract useful insights from data. And here also, So there is a lot of misunderstanding when it comes to data science. It's very often confused with AI. It's not AI and it's not machine learning. It is part of a process that can lead to machine learning, but we can also stop on only considering the data and doing a small dashboard with the visualization and the statistic summary. Most of the time of a data scientist is used for data preparation. So before the machine learning and all the stuff, we need to prepare our data, and it's not an easy task. So if we look at the workflow, first is the data collection, which is a very tiring task on itself. If you ever created or try to create your own machine learning model, or if you try even to do any research, you know that the collection of data is one of the hardest parts. Where we can get the data. So there are databases. We have like, I think it's data.gov, with the American datasets. We have also our own Polish one. We have a website like Kaggle, which probably you use. Also, we can collect data ourselves. We can have the data from surveys if we are also researching some topic. The data can come from our own experiments. And also we can have the data from, for example, a company that we work for. Then we have to load the data. And loading data also has different things we need to look at. So, for example, what type of data it is? Do we have it in a CSV file? Is it an Excel file? Maybe you would prefer to have it in completely different data structure. The more data we have, the more time consuming is also the loading data part, which we'll also talk about when we will talk about the difference between pandas and polars. Then cleaning the data. So the data that we will usually get, normal data, not generated data, because this is also a very important thing that you should look out for, especially on sites like Kaggle. There is a lot of generated data sets, which are maybe good for practice, but they will not give us the real feeling of how to handle the data if we want to use our skills in a workplace or in a research, because in a normal data set that was collected, for example, from respondents, we have a lot of things to fix. And it takes only one small mistake in, for example, creating questionnaire when you, for example, didn't mark one question as required. And suddenly you have huge data sets that you work for and you collected it for years and you don't have half of the data. Or maybe you didn't expect people to write some things. For example, if you have a collection of data that you expect people to write something clearly. So, for example, you are asking about the experience in a workplace. You don't really have any control on what they are really putting into there. So, if you work with people you know, you can't really prepare for everything. How they are using it and how you interact with them, it's very complicated. Also, the interpretation, even if you have a survey or if you have any other input from that is generated by other humans, sometimes they can misinterpret the language you use. Especially I see it in younger people when they don't have the same vocabulary, for example, and they don't understand some words. So especially if you are doing some social studies or psychological studies, and some of them can interpret the question differently than others, and then you will have a very strange or non-correlation, or you will have some different noise in the data. So all of that is the process here in the cleaning. You can change it. You can find some things that maybe need to be fixed before you even do other stuff. And now is the transformation. So with the transformation, it's also a little bit about the cleaning part. We need to fix the types. Sometimes we need to rearrange the data. So maybe we can have the, longitude and latitude of some point, but we want to have the distance. Or maybe we have years from which this person started to work in our company, but we want to have the amount of years. So we want to group, we want to change the type, we want to modify the data to fit what we want to do. There's also one important thing. We shouldn't change our plans, for example, for a model to fit the data, but find the data and change the data to fit what we are supposed to do. So first, we need to know what are our plans, what we want to research, what we want to do with this data. If we want to do just a dashboard visualization about, I don't know, what's happening in our company, for example, or if you want to have the data to predict something, we need to have clear overview of what our plans are. And this workflow should help us to attain our goal, not to create our goal in the process. Then we also need to do some data exploration. So we can at this point do the exploratory data analysis, which is basically moment when we ask questions about our data. So how many rows we have after all the cleaning, after all the transforming, what are the average values, if we have something completely missing. So maybe it turns out that when we cleaned our data, one column is completely gone because for some reason people didn't answer it because we didn't mark it as required. So for example, 10,000 people, only 500 answered. So this column is completely useless for us now. We can also see if there are any outliers, if there is something that we missed. So maybe we have some answers that were completely out of scale, which can tell us few different things. Sometimes it really happens that we have like one very different approach, or one very different person that is completely different than the other in terms of what we are asking about it, or different, we have something that is unusual in our data, but most of the time is some kind of a mistake in measurements, or maybe in just working with people and misunderstanding, or just someone who is making a joke. So this is the moment not for us to test our goal. Yeah, so this is not when we are saying to ourselves, yeah, for example, we wanted to talk about our company performance. It's not the moment we are answering this question. It's the moment when we are understanding the data before making the decision what we are going to do next. Because in the workflow, we can always, and we usually always go back, especially after, if we are doing machine learning and we fit our model and we evaluate the model, usually there is a lot of redoing of the whole process over and over again. So after that, we can visualize our data. And we are doing it mostly because not everything we can see clearly in numbers. Visualizing data can help with seeing patterns more clearly. It can help us see what is standing out more. Sometimes it can help us see more things overall about the data. So we can also, in some cases, stop at this moment and go straight to presenting results, because sometimes when you're a data scientist, this is what is needed. A dashboard with the summary of statistics, with the visualization, and comment about it. But if not, we can model. It's optional. It's when we want to create a machine learning model to maybe form a prediction based on our data. So we can not only predict something, but we can also classify things with this. So it depends what you want to do. And the final results. So this is at the end. If you stopped at the creating a dashboard, you're skipping model. Usually also, if you visualize the data, you can see that there are, for example, some points very far away from what should be. So all this strange noise is happening. You need to also go back to cleaning the data and transforming the data. If you also include the model, you can also go back even to collecting the data, because it can turn out that the data is completely useless and you need to redo everything. But if everything is okay, you can go to the results and you can present the results to whoever you are is interesting. If it's like a scientific research, so for example, you're publishing it. If it's inside a company, you're just giving it to higher ups. So now, why Python? Python is a language that is easy to learn, open source. It has many libraries and large community. This is what few years even ago was main things that I was talking about when explaining why we are even using Python. But now I think I'm happy to say that it became the industry and research standard over the years. So if you look into research, if you talk with your colleagues working in different companies, you will see that Python is used almost everywhere. And it also gives us this community and a lot of different possibilities for Python. Of course, it has some disadvantages, like, for example, Python is not the fastest language, but also Python is not like a pure Python language if you're using it for machine learning and data science. You will have here also the comparisons. Pandas is written in C and CPython, if I remember correctly, and Polars is written in Rust. So we have many libraries, but these libraries are the most maybe not important but popular. You probably know them all. NumPy, of course, it's like a biggest library that you can find everywhere. Everywhere in each of this library, almost there's a NumPy library implemented. Pandas and Polars, which are for data manipulation. Matplotlib for plotting, of course. Seaborn usually for the visualization. And scikit-learn for machine learning. I think you had during this conference, you had the opportunity to use each of these libraries now. So where do pandas and polars fit? We have our file with our data. It can be a file, it can be a database. Then we use pandas or polars to, as was before said, transform this data, load the data with this. And then After that, we can visualize the data and model data. So when we looked at our workflow, this is what we usually use. Pandas also have some visualization methods, but they are usually using Matplotlib. You can also use Matplotlib to visualize the data. Mostly it is used to work on data frames. And you know what data frames is? Who works on data frames? Yeah, so that's perfect. I will just, go very fast. Data frames is just like a table, like an Excel file or something like this. What's important that we have the columns, which we can call variables, because they represent variables. Yeah, so they describe the properties. And then we have rows, which are observations. So each row is one observation with different values of each variable, so the properties of each observation. And what are the differences? So first difference is Pandas is much older, which also make the community much larger, and it's more mature library. Implementation, Pandas is implemented in Python and C and Cython, so Python with C, but Polars is implemented in Rust, which makes it more optimized for larger data sets. Execution model for Pandas is eager, and for Polars it can be eager and lazy depending on what your needs. Do you know what I mean by the execution model being lazy? Yes? Yeah. So you don't have to do everything. Yeah, you can really control everything what is when loaded. You can also do multi-threading. In Polars, it's by default. In Pandas, most things is single-threaded. Memory efficiency in Pandas is not bad. You can really implement and get huge data sets, and it will work okay. But Polars is often more memory efficient, but it also goes from the lazy execution model that you can implement. Syntax for Pandas is more mature and familiar, of course, because it's an older one. And Polars is more declarative and more expression-based. Ecosystem, as I said, for Pandas is large. We have large community. We have a lot of books. And Polars is rapidly growing, but not what is when we see in Pandas. And learning resources also for Pandas, we have everything. We have books, we have documentation, we have like conference, we have keynotes, we have some other internet help. With Polars, it's increasing, but still, I think their documentation is the biggest one now. I don't know if there are any like huge books on Polars. I would have to research it more. And so what is best suited for Pandas is for general purpose data analysis, teaching and research. Of course, research, if you don't use very, very, very big data set. And Polars is high performance data processing. So depends what are you need, because now the fact that Polars can be much faster, you can be more minded with the memory. It doesn't mean that you have to forget about pandas. Pandas is still very good library. It's very good for teaching, especially if you don't really understand everything. Pandas is better if you need help, because there's a lot of resources, and also because there's also a lot of resources. All the chat GPTs and other AI agents have more resources to help you with, which I know people are using it more and more for education purposes. Yeah. I'm not sure, because I don't know if they have anything in Rust. I think everything they have is in C. So I think it also depends how the polars will go. I think both of the libraries will try to find their own, place to be in the ecosystem. And pandas is not as bad when it comes to efficiency. You can see it if you have very, very large data sets. This is where you can see the polars winning, and also polars has very nice different ways of, for example, loading the data, where you can load only parts of data, not everything at once, which is also helpful if you have very large data sets. It also, I think, will change depending on how our tech side, the hardware, will go, because if we stop on optimizing, and I know that some people are using polars because their hardware is not good enough to load something with pandas. It will just take too much time, and polars allows them to just load from huge data sets what they need at the time, which is helpful for them very. We'll see. I don't know. I see a lot of Rust libraries popping up, which is interesting for me, because Rust is not that, it wasn't such a popular language, at least in Poland. I don't know how is it from where from. Is it Rust popular in your places of working? Yeah, exactly. And we even had this problem among the students. We were searching for someone to do some project in JavaScript, and we couldn't find a single soul using JavaScript, but we found Rust programmers, and we're like, what's happening? Why people are using Rust? So I think maybe it's the future. I don't know. I need to look up what's happening in Rust now, because the same way I thought PHP is going to be dead, and it's completely not that. I think it's completely opposite of that. It's really doing very major stuff, like objective programming and all, even like some kind of machine learning and AI is coming into PHP. Okay, so now I will move to small tutorial. Let me just find the window. Okay, now I need to. Oh. Sorry, but I don't know if you have also this problem, but for a few months now, even more, I have this problem that I can't choose a window on a MacBook to mirror. I need to do it manually for like, I can't choose from this upper when I can mirror only one window in full screen. I need to do like some hoops. So yeah, here when you go to the supporting material, it should redirect you to the GitHub. We are going to work on this data set mostly. It's about Palmer penguins. It's now quite popular data set. It's supposed to give you another option to maybe not use the undead iris set, which is usually used for every machine learning and data science examples. Also, there is an extended version, which you can use then in the challenge, for example. So here's the live tutorial you can follow. If you haven't installed the required libraries, if you don't have them, so you should just uncomment this one and also run it. But if you have it installed, it will just tell you the requirement is already satisfied. So here is the basic loading of data. As you can see, it's almost identical. So we are not going into the collect function, because you have in Polars this one, which you can select what you want to really do with the data set. We are going just to do basic things that you usually do, and I think you should see the difference between the libraries, but also you will see that they are not as different. So the head function is the same for both of them, and it does exactly the same. So it will show the first 5 rows. And then we have the info function, which is the information about our data frame for pandas. For polars, we also have head, and we have the schema. You see, it's a little bit different. You have also other different functions that maybe are better suited for this comparison. This is what I chose. It for me was the most similar. It will tell us the column names and the type. Then in cleaning data, first in pandas we'll see how many of the rows are with the here's none. So in pandas, null and none is almost the same. It's treated almost the same, but in polars it's different thing. So this is also a thing you need to be mindful of. In pandas we have the drop NA, and if we just rerun this command, we see we have now no empty rows. No rows with empty values, yeah, that's way. Then in polars, you can do null count. This is how it's going to look, a little bit different output. Then drop nulls is the function. Of course, we have drop none and drop null. There are functions that do similar thing, but a little bit differently. But drop nulls is what more or less drop NI in pandas does. And after that, we see we are also have our data cleaned. Now, selection of the data. We can see now when I was talking about the more declarative and expression based polars, we can see it here, because for pandas we just use this syntax. Of course, we have like logs and e-logs that we can also use when selecting data. For polars, we have a select function. It's also one of the main different things between data frame in polars and in pandas is that in polars you don't have the indexing like you have in pandas. Each row is like a separate object. Yeah, and in pandas you have the indexing, and the indexing is very important for the data frame. You can even see it here that we have the indexes put here, and in polars we don't have the indexing. Next, the filtering. Here we have example. What is happening here is we are just finding all the species with that name. So if in the column species is this value, it will give us this in an output. And to do the same in polars, we have function, again, filter. You see the difference? Here we don't need a function. It's a little bit different syntax. It's more it looks more like Python syntax for me. You know, in Python, you have the data structures, and you are really used to the way of using, you know, different parentheses to different data structure and to getting into the information that's inside. So when you use lists or tuples or anything. Here, we mostly use functions. And transforming, here we are creating new column that will have a value dependent on the value of another column modified. Also, as we can see, pandas syntax is a little bit more familiar, a little bit easier. But in polars, you need to do it with functions. So first you need to use the function with columns. Then you need to have a function to tell polars which columns to use. Yes. Then you have to create an alias to create the next column, and it can be a little bit more complicated to someone who is more used to the basic Python syntax. Yeah. This is also what I think. It's more to SQL or a little bit more to like. So Python has this way of shortening everything and doing things sometimes under the hood, and here polars is forcing you to do things more. More intentionally, yeah, especially also. And pandas had problem with it because they had problem with their own syntax when sometimes people were working on a copy of data frame instead of a data frame, or were working on a data frame thinking they working on copy of the data frame in a memory, which also created some problems. They are fixing it now. They're forcing you to use a log function, but it's generating a little bit of problem. The syntax is much simpler, so you can understand it completely. You see it and you understand it. There's like nothing really complicated about it. You don't need to know what function is doing what. Here, it's a little bit more complicated. And yeah, that's really very good observation that it looks a little bit as SQL, because also at the end, the syntax, the whole, how is it positioned, that at the end you have the name of the column and all. But it's doing same. And the example of the aggregation here is a little bit easier maybe, but still here in pandas we have group by, of course, and group by will give us the grouped sections, yes, and then we can take from the section from, for example, this modulus, and then apply min function to it. In polars, you have also group by function, but then you have to use this function to do what exactly is happening here with this square parenthesis, yes? So to take the body mass, and here is the way you use the polars function for mean. So we are not using a dot to use like this the insert function of the data frame. You have the function from polars, which will calculate the mean of this body mass, and it will the aggregation will be processed with this function. So yeah, here we know that this is an aggregation, but it's a little bit hidden. Here you need to use the function for it to do it. So that's the very basic stuff. Do you have any question about it? I think it's easy. You should be able to follow it up. So I prepared exercises. It's the easy one. It's very close to what we have, and if you want to see the solution, you have it in the file that's called solutions. But also I prepared you another thing, and a mini data analysis challenge. You can try to use pandas and polars to answer the questions. And I think that's it for the theory. If you have any question, you can ask me. These questions are for the basic data sets. So it should force you to use all the function that were presented. Do you want me to leave this questions? Yeah, okay. So I will do it a little bit. Yeah. So it's used for exactly the same things that iris data set is used. So when you have the examples of both classification and regression machine learning. So because you have both numeric data, which can go for regression, and also you have classification data. Extended one has even more data for both, and it's usually used for training for, you know, when you have students, when you are just starting out to understand how to create machine learning models. So this data set is about the species of penguin, but I think if you want very much, you can also find a way to make a regression model out of it. Maybe I will give you a little example of the first question, because all the other are. So which species has the highest average body mass? So if you use pandas, here when you have the mean, this is from the tutorial, the first, it's would be easy to just go max, yes. It will give us the value, but we want to know the species, yes. So you could, if you for sure, if you are not very versed in different things, because in pandas you can do very different way, but the more like step-by-step way would be this kind of thing. So you have deer, then you go log, because this is panda tells you to do. Then you have to give you the data frame. So this whole thing, you can also hide it in variable, but everything here, the mean, yeah, which it should be looking for, and then you need to compare to the max value. And this will give you what you want, yeah? If this is the output you are looking for example. But in polars, all you have to do is add the select and max, because polars is looking at the data frame differently. Each row is like different object. So, and it's not using indexing to do anything, which makes it a little bit easier to select a different part even for from smaller series than it is in pandas. Do you have any questions to this? Yeah? Here? Yeah, but it shows the Modibus, and if we would like to show the species, what we should add here? What do you think? Yeah? Mm-hmm. Mm-hmm. Again what? Again what? What did you after aggregate here? Mm-hmm. Mm-hmm. It's also a way to do it. Yeah, it's also what we can do. But we can also aggregate the output from this one. You need to think about it like if you were writing like the SQL question to the database. Here? So you mean like this? But what happened here? Yeah. So what else we can do here? Mm-hmm. Yeah. Maybe let's go to Polar's documentation, to the select, and see if we have here some examples. We don't have a lot of examples here. Okay, but here we have information what we can give it to it. Yes, we can give the columns. But why do you think it's giving us this? What if we just go like this one? It works, yes? We have 3 species. And then can we maybe change this? Maybe we can do the max calculation here. Try it out. I will give you like 3 minutes, okay, to try it out. Here are the questions. Someone wants to do something else than this example. Do you have it? Yeah. So, sorry, where is it? If you look at the things we did, we need to do the filtering. Yes? So we can, for example, filter out our output, which is what we are also doing here, but with a log function. Yeah, you have the same or a different way? Yeah, which one? Mm-hmm. Mm-hmm. This is also how you can do it. But then you had only species or species and body mass? Only species, yeah. So this is the way you can get the whole row from it. Mm-hmm. Yeah, also. So has anybody did any other challenges, or maybe I'm sure you did the exercises? Yeah, they were easy. So the second one is very close to what we did just now. Anyway, you can take a photo of these changes if you want to work on them. I will try to post this slides also, but it's in Keynote, so I have like some animation, so I just need to redo it to be more readable for you in the PDF format. If you have any questions, you can ask me, but so you know, I'm not the expert on polars. So I may have some also difficulty to answering every questions, but more and less I work on it, more in pandas, of course, but also sometimes in polars. And yeah, I hope it wasn't too boring for you. Maybe it was a nice difference from every very hard tutorial you could barely follow. I hope you could follow this one, and yeah, thank you for attending.